of time today. I have this little reference chart that is basically stuff that we've talked about before, but I just wanted to offer it to you as an opportunity to kind of solidify your understanding and have a nice thing to look at in April and May when we're getting ready for the AP exam. So this chart here is just lots of shapes and lots of axes on it, so we can talk about some displacement versus time, velocity versus time, and acceleration versus time graphs, just so that we remember how everything is related. So I've got 3 stories for you. The first one is very simple. The displacement versus time graph looks like this. And as you know, because we've talked about this for quite a while, this is a situation when the object is at rest. Pretty unexciting. If it's at rest, we're going to look at the slope of the position versus time graph to find the velocity values. So I'm going to say for velocity values. And since the slope is 0, that means that the velocity values are going to be 0, which is not a surprise. Because it's at rest, it's not moving. So the slope of the d versus t graph, or the x versus t graph, gives the values for the velocity graph. Hold on just a second. All right, sorry about that. So anyway, the velocity is not going anywhere. So the slope of the displacement versus time graph gives those values. And then just like we did going from displacement or position to velocity, we're going to do the same thing going to acceleration. So we're going to look at the slope of the velocity versus time graph for values of acceleration. And oh my gosh, the slope is 0. Also not a surprise, okay? That's going to be the values for the acceleration. Let's take a look at the second one. So for the second one, again, we're going to do displacement versus time, velocity versus time, and acceleration versus time. In this story, oh, something very different is happening. You've seen this before, friends. This is just an object moving away from the origin. At a constant speed. We know here that we can look at the slope, and the slope is both constant and positive, which means that the values here will be both constant and positive. Okay, so the values are constant and positive. That's going to give you a horizontal line. We look at the slope of this line, and the slope of this line is 0, which means that the values here will be 0. Bam. So again, in this one, because the velocity is not changing, that means there is no acceleration, so acceleration is equal to 0. You might notice that there's a little like thought bubble that's sitting next to the displacement versus time graph, and that is to kind of lead from that slope being constant, just to remind us that at any point we can find the velocity of the line by looking at the slope, and we can find that by looking at the change in position over time. This very last one over here, again, just kind of making it a little bit more interesting with each passing set of graphs, Vx, position, velocity, and acceleration. In this case, oh, we've got a curve, a nice parabola. In this case, the slope of that graph is now increasing and positive, okay? Which means that the values of the velocity graph will be increasing and positive. Up we go. Okay. We look at this one, the slope is constant. And positive, which means that the values here will be constant and positive. Okay. This is a story, as we know, of an object accelerating away from the origin. Okay. In this little thought bubble, again, just to kind of remind ourselves, we know that the acceleration can be found by looking at the slope, the change in velocity over time. So again, this is a pretty straightforward review given what we've done so far this year and the last few days, but it will be a nice reminder moving forward, especially this spring. Thanks so much. Have a great night.